Our panel is centered around the topic of beaver restoration is restoring beavers, which sounds like a tautology, but it's actually something very deep to think about. And starting us off, we're gonna have a couple of presentations really quick just to kind of center, focus the topic, and then I'll sit these folks down and ask them some questions. So starting us off is Jessica Doran.
Hi, everyone. So my name is Jessica, and I'm with EcoMetrics, where we try to work really hard to use applied science to forward wetland restoration efforts. Our work has always been focused here in the headwaters of Colorado, but it hasn't always been focused on beavers. When I first started, this picture on the right, that was the image of a healthy mountain meadow stream. And if you had an impaired stream and you wanted to restore it, that image on the left, that's what restoration looked like. Now, during the same period, we were also working on developing a wetland assessment that was founded on the idea that system health is related to the severity and extent of anthropogenic alterations or impacts to systems. So a wetland with no impacts would be considered healthy, most healthy if it had no impacts, and it would be performing its natural suite of functions that it had evolved to over time. So using this idea and applying it to streams, we went out into our area to find the most healthy wetlands or streams we could find. And every time we found a spot that didn't have many impacts, it didn't look anything like the models and the pictures I had been shown. Instead, it looked like this. They were either occupied by beavers, creating complex wetland systems, and even more often, there was a lot of evidence that beavers used to be in the system, but the beavers were missing, leaving behind a simplified channel and a dried wetland. Realizing the extent and severity of the impact of beaver loss triggered a massive recalibration for us. We went from measuring minutia of channel form to trying to understand this largely overlooked stream type, or wetland, as some people call them. Studying beaver systems has been very fulfilling so far, and as we'll talk about today, we still have a lot to learn. But probably one of the most profound observations we made after many, many trips to the field is that there's a lot more suitable beaver habitat than there are beavers on the landscape. From the restoration practitioner's perspective, we wondered if there were ways to improve habitat to get beaver back in the system. To this end, we experimented with ways to manipulate flow patterns, riparian vegetation, aquatic habitat, and we've become pretty good at mimicking beaver dams. If you guys can see right here, we raised the water table and created overbank flows and have some deep aquatic habitat. We added a lot of organic material to the stream here. And that kind of begs the question, do we even need beavers, or can we humans just mimic what they do? That should be enough, right? We did a good job. This is an awesome example because beavers had a very clear answer for us. So much so they moved in and did work on our humble start. So much so that we had to broaden the view of our photo point. And beyond that, like really the site potential, the recovery potential of this site, it just made us have to rethink the whole thing. This is very impressive, right? But we don't just have to use pictures. We can also measure this change. So here's a section of our treatment site just downstream of the photo series you saw. The blue line shows a transect where we installed groundwater wells, arranging them across the valley, and a cross-section allows us to plot the water elevation. So this is pre-treatment. This is after our mimicry work. And next we have the same graph again after beavers recolonized the site. So as we can see, we can work hard and we can influence these systems, but beavers are the true agents of change. They're also the true agents of sustainability. As practitioners, we really need to pause and ask ourselves if mimicking beavers is getting at the heart of restoring wetlands. Is the system healthier in the long run if we mimic one aspect of beaver activity, or is there an opportunity to explicitly focus on expanding beaver populations so they can do the work that they are best at? Here's another example. Same project. This is our effort. This is their effort. It's really quite humbling and impressive in the best ways. What you can't see in this photo point, or this view from the photo point, is the massive level of change that's happened all across the riverscape. The scale of change is really best appreciated and measured from above. So here you see an aerial view of the treatment and reference sites and a graph of surface water area expressed as a percentage of the total riparian area. The lower yellow line represents these values for the treatment site, where there are no beavers, and it's a simplified channel. The blue line is the reference site just upstream, where there is an existing beaver population. So pre-project 2017, the treatment site was at 5%, and the reference site was at 17%. And then it didn't forward. Did it get it? No. Are you guys, is it suspenseful enough? What's gonna happen?
I have no solution. I'm just coming up here to push some buttons. We're gonna hope. I like to escape. No.
How about this one? No. What about the mouse? Let's try that.
We got it.
Okay. So here, in 2022, we did our mimicry work, and we increased it from 5% to 7%. And then the big change on the site happened in 2023, after the Beavers reoccupied the site and took over maintenance. Surface water area jumped from 7% to 28%. The reference site also rose during this time period. So immigration of beavers to the section we treated was the real difference maker. And this really highlights the importance of restoring nature's own natural processes. Oh, I hope this one works. So in our case, the journey to realizing the importance of restoring beaver populations has been very hands-on and really quite obvious. And when we consider the principles of process-based restoration, it really is the only way to ameliorate the root cause of impairment, work within site potential, and at a scale that's in line with the problem.
One more example. You all know that beavers are, you all know them as a keystone species and ecological engineer, and that they're basically the engine in a biological machine that turns simple stream channels into complex wetlands. And when beavers are absent, the machine shuts down and wetlands devolve back to simple channels. The component that's most obvious when it's missing is beaver dams. So the obvious solution to beaver absence is to mimic beaver dams. If we do a good job, the analogs may restore some ponds and some wetlands, like Jessica showed. And if we're lucky, mimicking real habitat will attract beavers dispersing from neighboring sites. And this time we got lucky. So here we are in August 2021, before any work was done. A month later, with some analogs of beaver dams that we built. The following summer, after beavers reoccupied the site and started doing work on their own, and again in the fall after more work by the beavers, ta-da! A simple stream restored to a complex wetland. Success, right? High five. By the traditional form-based way that we have become used to evaluating restoration projects, comparing condition before and after treatment, it sure looks successful. But let's not be so quick. If we're serious about process-based restoration, then we're obliged to match the scale of restoration to the scale of the problem. and we're obliged to be explicit about expected outcomes. Success must be an appraisal of the degree to which natural processes are operational, and that means restoring a sustainable population of the keystone species. Beavers are animals, and unless we fence our project off and manage it like a zoo, they're free to roam and they're subject to all the environmental and human factors that affect any species in the wild. Their presence on any particular site at any particular time is a function of population dynamics and life history. It's a biological question. Restoring a keystone species in the wild, it's an ecological problem with factors that operate over longer time frames and larger areas than restoration practitioners are usually thinking about. So, let's expand the time scale. These photos highlight pond area, providing snapshots of beaver activity over the past 70 years. These ones do, actually. There was a peak in the 1970s, then the local population crashed, partially recovered, and crashed again to zero in 2020. The spike in 2022 is the result of our work and why we were just high-fiving. We can be proud, but we can't just call the site restored and move on. There's no guarantee that the beaver population won't crash again, and indeed, we should expect that it's going to. We need to be explicit about these expectations, and at a minimum, this calls for the use of relative terms, not absolutes, when reporting our effectiveness. Beaver restoration, it's more of a percentage game. Expanding the geographic scale puts our project in the broader context of a watershed. The thick green lines on this map show reaches with frequent or pervasive beaver activity, using mapping that's similar to what Sarah just showed us. Thin lines in this map show areas that have sparse activity. And we can overlay our map of where beavers are, the one I just showed you, to a map of where beavers could be using a capacity model, like the Beaver Restoration Assessment Tool. Places that show up as blue but not green on this map are historical beaver habitat that's currently unoccupied. Compared to historical capacity predicted by BRAT, current beaver activity from this map is about 1.5%. So that means 98.5% is inactive. Well, BRAT's the first landscape scale beaver capacity model to gain popularity and regular use. And it deserves credit for helping people think about population biology and landscape ecology, which is a huge first step. We also have to realize it's an extremely simple algorithm that relies on really coarse data. So BRAT's a great place to start your investigation, and not necessarily a good place to end it. A more professional assessment of historical capacity using more sophisticated methods and more rigorous data yielded this result. And by this estimate, 16% is currently active, which is better, but it still suggests a severely depressed beaver population. We can also remove reaches that no longer support beaver activity due to existing constraints or severe degradation to get a better estimate of current capacity. Compared to historical carrying capacity, now we're looking at 16% is currently active. 15% is not really practically restorable due to constraints or past damage, leaving about 70% unoccupied and potentially available for restoration or recolonization. Or we can map it this way, where open circles are unoccupied patches and solid ones are occupied. The connecting lines are the aquatic corridors through which beavers tend to move. Not only is the population depressed, it's also segregated. And this should start you thinking about things like stepping stones. Relatively isolated clusters are separated by spans of unoccupied and suboptimal habitat. And at this scale, the effect of our work, the mimicry work we did on one reach, looks like that. Now let's just consider what happens if we trap beavers out of a conflict site in red and move them to an unoccupied site in blue. The effects of that look like this. Technology, like Sarah just showed us, makes it easy to look back in time and watch how the distribution changes naturally as patches survive or wink out, and as empty patches are colonized. Viewing our actions in this ecological context is a key to setting realistic expectations. We can also draw on basic beaver biology, a field that, in my opinion, is currently underrepresented. The more we know about the factors that define beaver population dynamics, factors like reproduction, migration, dispersal, site selection, habitat suitability, and vulnerability to things like diseases and predation, stochastic events, and of course, interactions with people. The more we know about these things, the better we'll be at beaver restoration. It has to be more than just mimicking beaver dams, and it has to be more than just moving animals around. Beaver restoration has to be restoring beavers. The goal of this session is to inspire you all to think critically and scientifically about restoring beavers, and on scales that are longer than a few years and broader than reaches. We have a lot to learn, and the relatively untapped fields of ecology and population biology have a lot to offer in making beaver restoration a science-based practice. So next up is another scientist, Torrey Ritter from Montana.
Okay. The most torturous thing in the world for me is to have a very short amount of time to talk about beavers. So it's good. It helps me focus, but this is a time where I actually have to have some notes, which is uncharacteristic for me. So I had about a 15-hour drive down here, which is plenty of time for me to completely rethink how I wanted to approach this. So I'm going to jump around just a little bit. I apologize for that, but hopefully you'll see why here. So I really wanted to start with this slide because I really love to think about beavers this way as a disturbance regime. I put them right up there with fires, with flooding, with grazing, these sort of periodic hits to the system, kind of punches to a portion of the ecosystem that if it's in balance with other processes in the ecosystem, if it's happening at appropriate spatial and temporal scales, it leads to habitat heterogeneity, to high biodiversity, and to these really wonderful systems that also provide a lot of ecosystem services to humans. And when I think about beavers in that context as being a disturbance regime on the landscape, then those abandoned and relic colonies, it really jumps out to me just how incredibly important those are. Maybe as important as active colonies on the landscape. One of the reasons for that being the successional stages that beaver infrastructure goes through as it degrades from being actively maintained by beavers to being blown out to kind of gradually being consumed and eaten up by that stream and by time. Those successional stages, each one of those, has its own set of characteristics and properties that allow certain plant and animal species to take advantage of that place during that stage. At the same time, all of those different successional stages of beaver infrastructure also play into these restoring these natural processes that we're all trying to get back into these stream systems that will hopefully lead to that golden, self-sustaining, restored state. And this is what we're seeing in a lot of these sort of conceptual models about how beaver restoration work, like this one from Pollock et al. It's the same thing you're hearing about in LTPBR manuals and lots of other places, where they're talking about feeding structurally starved streams structure. Each one of these processes has basically an abandoned colony stage where those structures are starting to degrade. And that is really critical to the overall process of getting the stream moving and diversifying within its floodplain again. But I want you to notice a very key thing that happens here on that left panel, which is the beavers move in, they build their infrastructure, they move on for whatever reason it might be, that infrastructure starts to degrade, but then new beavers move in. Specifically, new beavers move in before that previous infrastructure degrades to the point where it's unusable or unrepairable by that new set of beavers. So that process of beavers moving in before the previous beaver infrastructure is completely degraded is what keeps pushing the stream in the right direction. It's akin to us going into a BDA site or LTPBR site and doing more treatments. And so to me, if this is happening out on the landscape, then that is an indication that that site, that restoration area, has been reincorporated into that disturbance regime that the beavers are creating. And that disturbance regime is driven simply by normal colonization and abandonment dynamics that should be happening in a healthy beaver population. It's been said by many of other people, but we don't want every territory occupied within a beaver population area. There needs to be abandoned and relic colonies to sort of keep things moving and keep that disturbance regime engine chugging. So when I see the results of the things that like Jessica and Mark just showed us, where beavers have moved into these restoration sites and just completely outdone whatever we could hope to do, that's sort of this first level of success. But what I'd like to see is them to come back in 10 years or 5 or 10 years, come back and just continue those time lapses. What I'd like to see is the beavers build up that infrastructure, make a big wetland complex. Then I maybe wouldn't like to see this, but in some ways I'd like to see a whole group of mountain lions come in and just wipe out every beaver across those colonies, just completely eliminate them. And then I'd like to see those structures start degrading. And maybe you'll see on the drone site, you'll see Mark and Jessica out there just panicking about it. The whole thing's unraveling. But then I'd like to see beavers move back in again, and that's their final slide. The beavers have moved back in and started repairing that infrastructure before things unravel. And to me, that's that sort of second layer of success, that indication that we have brought this restoration site, we've plugged it back in to this beaver disturbance regime. Now, to re-enter that beaver disturbance regime, obviously, we need to know where it's basically functioning on the landscape. And not surprisingly to anybody in here, where it's functioning is where we have a consistent supply of dispersing beavers looking for places to settle down. And so I like to think of these dispersing beavers as kind of tentacles, reaching out across the landscape from these source colonies, looking for somewhere to settle down. But unfortunately, beaver dispersal can be kind of a complicated thing to try to take advantage of in a restoration context, and that's just because beavers are a very, very unique species. This is especially difficult in landscapes that a lot of us are working in, where the high-quality habitat for beavers is already taken up by beavers. We're mostly left with these semi-degraded stream channels where we are trying to get the beavers to settle in sort of suboptimal marginal habitats. Well, that low-hanging fruit has kind of already been taken up. Now, beavers exhibit a life history strategy known as delayed dispersal. So they live in such close-knit family units with closely related family members, and they have such strong sort of fortresses and high survival rates when they have really well-established colonies, that there is actually an evolutionary driver for beavers to stay at home and help out with the home colony, help raise closely related family members, versus going out and trying to just make a go of it in pretty crappy habitat or a pretty cruddy site. And so they actually there is an evolutionary advantage to staying at home well past the age of 2 years old sometimes and waiting for a really good opportunity to open up on the landscape. And to beavers, what the dispersal literature will tell you is that the really good opportunities seem to be either they move in and take over a spot in an existing colony, or maybe especially they find some sort of abandoned or relic colony where they have previous beaver infrastructure to start with and to build from. And that brings us back to this idea of this abandoned and relic colony stage in the overall beaver dispersal regime. That beaver infrastructure that's degrading, it has its own sort of properties in driving these natural processes, but one of those is that it's highly attractive to bringing other beavers back to the site eventually. If you saw Jordan Kennedy's talk next door about channels, the channels and tunnels that the beavers can dig potentially being really important for where they show up on the landscape, this previous infrastructure is really a critical component. I didn't really get to go into my beaver dispersal study and all I learned about them, but one of my biggest takeaways from that entire study was just how incredibly critical previous beaver infrastructure is to driving when, where, and how dispersers are moving across the landscape. There's just lots of amazing stories to tell you about that, but they seem to truly actively be avoiding areas that don't have any previous beaver infrastructure. Even just a super old lodge out there in the middle of an otherwise pretty untouched stream will be heavily, heavily used by dispersing beavers. So fortunately, when we're building BDAs on the landscape, we're kind of taking the first big step to mimicking an abandoned colony that seems to be this very attractive thing to dispersers on the landscape. But great researchers, some of that are in this room, are starting to find out that there is a lot of other components of beaver infrastructure that is not only important to them being a keystone species and an ecosystem engineer, but may also be really critical to sort of inviting beavers to return to the site. So while it seems like we have got really good at mimicking beaver dams and beaver dam complexes, there may be other infrastructure that we need to mimic, and we may not also need to mimic where that infrastructure is positioned on the landscape relative to existing active colonies where we have dispersers moving out across the landscape. So fortunately, we have a lot of efforts like what Sarah just showed, or the beaver dam census efforts, where we have this really cool thing, which is that we can see beaver damming activity on aerial imagery. Like, that's such a unique thing for a species. So we actually have the opportunity to map where this is occurring across a large area. And then we can pick out where are these beaver strongholds that we keep hearing about. And it's pretty easy to envision from a lot of the previous infrastructure, or a lot of the previous research on beaver dispersal, where those dispersing tentacles might be reaching across the landscape. And one aspect I didn't mention about delayed dispersal is when these beavers are staying at home, you will actually see higher beaver density leads to lower dispersal, but how they're defining dispersal in those studies means that the beavers are successfully leaving their natal colony and settling elsewhere. It doesn't say that dispersal movements decline, just that successful dispersal and settlement declines. What we found through our study and lots of other research is that these beavers that are sticking at home are making constant exploratory movements pretty much from the moment the ice comes off to the moment the ice comes on in the winter. Some of them will leave home for an entire summer, spend that whole summer up building dams and lodges somewhere, and then return home for a whole another winter with their natal colony. So we can take advantage. Basically, the closer we get to these big source colonies, the better chance we have of there being a consistent supply of dispersers that can help us reintegrate and plug back into that disturbance regime. That's just a really cool beaver complex up in the Upper Gallatin. I think I was supposed to be on this slide for something else I was talking about, but we can just appreciate that for a few seconds, because that's one of my favorite ones in the whole world. One of my hobbies is just finding beaver colonies on aerial imagery and looking how cool they are. So I guess the last thing I want to say, these dispersal age beavers, if we want to talk about restoring beavers at a landscape scale, these are our most valuable asset on the landscape. These are the workers that we have that can take these restoration sites from what we can do with BDAs to those unbelievable wetland complexes that we just saw in a lot of those other images. So you saw that we can't hope to mimic that on the landscape. We need these beavers to be working on it. And so I guess I'm saying what a lot of other people have said today. We need to try to prioritize where we're putting in these fake abandoned colonies and try to target those spots where we have the best chance of having a consistent supply of dispersers to get us back into this disturbance regime cycle. So thank you so much. I appreciate it.
So I'm going to skip a few of these because a lot of you have also been in the same room, but it was really interesting comparing notes with Torrey before this talk and looking at some of these beaver areas, and in particular, an area like this where we have what we've called a beaver stronghold, and then these kind of blue areas where we have these beaver stepping stones. So I just want to kind of encourage people as we're doing these restoration projects to, again, not just think on the reach scale or the individual beaver complex scale, but really nudge us into thinking about these beaver corridors within our larger riverscapes and watersheds, and thinking about, not, as others have mentioned, 100% occupancy all the time, as this image would suggest with multiple years of surface water, but just that these can fluctuate, that you have enough beavers in the system that you can at least maintain these wetlands, because wetlands will stick around often for years after the beavers have left. And again, that can be habitat for shorebirds, that can be habitat for ungulates, all kinds of species that move around with beavers in these landscapes. So yeah, I can just leave that up here, and I'll kick it over. Alexa, are you speaking? All right, I'll kick it back to Mark.
Is this thing work? Yep. I hope that introduction sort of stimulated a little thinking about thinking bigger and thinking biologically. I was inspired by Janine Castro this morning. I don't know, most of you know me as a restoration practitioner, but when I was in college, I was a population biologist. And to have a geomorphologist talk about how important population biology was, that was that was something. So the next thing I'm going to do is just ask a couple questions, and I won't be talking much more, but I want to kind of query this group. There's a couple practitioners up here and a couple scientists, and getting practitioners and scientists together, I think, is the most important thing we can do as professionals. The other guest we have up here is Alexa Whipple, who needs no introduction, from the Methow-Okanogan Beaver project. And she's here with her own special story of a long-standing beaver restoration project that in trying to be about restoring beavers has gone through a lot of changes in the things that they do and the directions and strategies they're taking. So my first question to these guys is in the idea of partnering with beavers, knowing what we know about their biology. How has that changed your thinking and what you do as practitioners?
So our project of relocating beavers, that's what we were founded on, storing more water for the future, one stick at a time. That is Methow Beaver Project's origin story. 2008, North Central Washington. By the time I joined the team in 2019, we had experienced 3 of the largest successive wildfires in our state, and looking at nearly half of our watershed burned and disturbed by debris flow events on a geologic magnitude. So when I joined the team and looked at nearly 10 years of relocating beavers, nearly 400 beavers relocated in our watershed, primarily from private lands in larger river systems to public lands in the headwater systems, I was asking, where are all the beavers? That's a lot of beavers to move around. There should be a lot of complexes here full of beavers and spreading out. Like, that was the idea, and it was a good idea. But in reality, it wasn't following beaver behavior, as you've heard a few talks about. It wasn't following the needs of beavers in how they are a very social animal, how they're very vulnerable on the landscape without their big complexes, how their connectivity and dispersal works. And a few people have said today, like, we need to know more about that. We need to understand that more. So when I joined the team and we figured out that, wow, not to say that relocation doesn't work, it just doesn't work in any way you do it. You know, like, you have to be really thoughtful and understanding of biology and life cycles. So we kind of switched gears from a relocation and outreach group to really prioritize preparing streams, especially in our wildfire impacted streams, severely incised, 150 plus years of grazing, mining, well, obviously beaver removal in the first place, road building, a lot of timber harvest, a lot of impacts, legacy impacts, and then the cherry on top, debris flows in massive mega fires. So we really looked at creating those, as I think of Ellen Wool saying, beads on a string. I like to call them pearls on a string. Maybe she did say that originally back in 2020 when I first heard her talk about that, and it really inspired me. And then to see Janine expanding on that idea around connecting with our efforts to mimic beaver habitat, to create the connectivity between viable habitat and therefore potentially viable population and dispersal opportunity. So we targeted restoring streams closer to our existing beaver populations. Just as EcoMetrics simultaneously was actively doing that in Colorado, Mark and I got together and we're talking about this phenomena we're experiencing, and he's like, yeah, if we can make it where beavers are nearby and can eventually get into it as they disperse, that might be our best bet. So that's what we started doing, is restoring with structure, veg, and close with where other beavers are, and then we're creating the little connectivity points up into the higher watershed. Storks didn't come along and drop beavers off 10, 15 miles away from other beavers back in the historic times. They were pushed into marginal habitat through dispersal. So that said, coexistence, keeping them where they are as much as you can. Stream restoration near where they already are, leading them into more and more tributary habitat where they can store more water, not be in conflict with people, and have slower stream power or lower stream rates, lower gradient in some places, but we work in high elevation or high gradient areas all the time with step pool systems and beavers. And then policy work on top of that. So like putting it all together, the big picture, we got to look at comprehensive holistic management and really try to understand what the beaver needs in order to capitalize on their incredibly good work and valuing them as a partner on this big, beautiful planet that we all want to save.
Yeah, I was really struck when I was watching Janine's talk as well with the stepping stone idea. And if you remember that graphic that had the two green squares, one at the top, one at the bottom, being sort of established areas, and then trying to fill in that middle part with these stepping stones. I think what I was kind of just emphasizing and what Alexa was just talking about is you can fill in that area with stepping zones. Another method to get there is to make those green blocks at the top and the bottom of the screen wider. So expand existing territory boundaries. So, there's two ways that beavers expand beaver modified habitats. They make existing colonies bigger, or they go out and they start new colonies somewhere. And I think both of those are critical components of sort of reconnecting metapopulations across the landscape. I just get nervous about those stepping stones because they tend to be a lot more vulnerable when they're starting new colonies from scratch. And I think in a lot of landscapes where we have these wide gaps between, maybe really robust beaver populations in a wetland complex or a river, good beaver complexes up in these headwater streams on public lands, and there's this giant gap in the middle of, mostly working lands. And I think some of those stepping stones that occur in that kind of dead zone for beavers tend to be, or can be, sort of conflict sinks where they keep getting caught up trying to settle in this patch of habitat and they keep getting removed. So just to emphasize again the importance of conflict management, not just in creating better tolerance for beavers in general in the landscape, but that also might keep that dispersing segment of the population moving when they do have to make long distance movements.
I think of partnering as has been said, understanding the needs of your partner, and then really being willing to kind of have a back and forth over time and be available. We have some sites that we've been monitoring for over 10 years, and it is, a lot of times you just kind of stand back and watch it do great things, and then maybe it kind of gets to this point where you're like, now it needs a little help. Maybe we want to go in. So it's very much an iterative kind of back and forth interaction with partnering with beavers. That's what I think of. And then the other big piece of it is understanding what they need. And I think that's why I'm glad that we're talking about this today. I think some of the biggest gaps in understanding what beavers need and beaver populations need, I think we need to get a better handle on what that is.
And to build off of the partnership piece with beaver, I think looking at hundreds of thousands of ponds across these huge geographic regions, you really start to be able to see or imagine what's going on the ground in terms of land and water management and just how we exist in beaver landscapes and how they are existing and where those two collide. And I think if anything, the coexistence piece and the need for that has really emerged as maybe the place we need to start. I think that, putting structures in streams, things like that is really important as well. But thinking about entire corridors and linking together these fragmented habitats, I really think is where we need to start. And particularly in places like the watershed we're standing in right now, there are a disproportionate number of beaver obstacles where the things that Jess and Mark showed in their images of restoration projects just can't happen in that way because of the distribution of land management and kind of acceptance of beavers. So I think there's a lot of opportunities there. And again, want to just push coexisting with our beaver partners.
In every restoration grant application I've had to put together, they kind of ask you how many acres of wetland or stream, how many feet of stream you're going to restore, and how much that's going to cost. A lot of what we're talking about now kind of flies in the face of simple measurements that that think about restoring a wetland or a stream as an absolute. So my question to you guys is, how do we articulate our expectations for restoration success with beavers specifically and with process-based restoration in general to the people that are funding it?
I'll start with that one. I mean, Sarah had a great presentation yesterday. I do think there is a specific challenge with beaver systems because they're so dynamic. And maybe this is for a lot of different streams types as we start to understand and kind of live with dynamism. Like we're very entrenched in like putting nature a certain way and then expecting it to stay that way. So there's some, I think just acknowledging that that's a really big shift that needs to happen is important. And then there's also some kind of science side too that we can work on. Like, I don't know what exactly success is. Like we're kind of been working with this more is better idea. I want more beavers on the landscape. Well, how many and when is success? And there's some big questions around that. So I think kind of we as a community need to be honest about that if we're gonna kind of keep, I think we can do better. I think we can get a little more bracketed than just more is better.
Is this one on? Okay. It is a conversation we're having with our funders as well, like the metrics that exist in our state grants don't fit for beavers, and so we have a lot of personal conversations, and that's how anything changes, right, is getting to a table with someone to talk about the challenges that exist and how do we resolve them. So one of the things we've started to do with some academic partners, because we're practitioners, but we're also scientists at the same organization, is what are the metrics that we are hoping to see an increase in or change in? And that's typically surface water area when you're working with beavers. Water is the key that it really brings probably most of us to this species, this keystone species, but also biodiversity and resilience and sustainability. But water really represents all of those things in many of our minds. And another one we've landed on is water transit time. How long is water sticking around in those systems? So that's one that we've added to our proposals every time is how long are we keeping it around? And I'll just give you an insight because the paper hasn't been published yet, but we work in control, treatment, and reference, beaver reference sort of study design. And control, nothing, hardly any structure, usually channelized, single-threaded channel, really fast transport. LTPBR, structure restoration, water transit time is 4 to 7 times slower than in a control reach. Can anyone guess what the beaver reference transit time is of the water? Anybody? 40 to 400 times slower through a beaver reference area. So this is the kind of shock that many of our funders are like, what? You've reconnected to your floodplain, yes. And not all of them act the same. It depends on what's upstream, it depends on the substrate, it depends on the geology and how big of a beaver complex it might be. Are there multiple complexes upstream of that area? But it's one of these places that we keep landing on better, more interesting, more thoughtful approaches to like how do we measure success, like Jessica said. And functional beaver populations, we don't know what that is. Nobody understands what a functional beaver population is in different habitats and different contexts. So we're still struggling on that front. So how do we keep helping people understand what the value of partnering with beavers is in our watersheds, we talk to them about that common ground. Typically, water is where we find the common ground. So keeping it around longer, spreading it out, then you get into the species it's supporting and all the other things. But
I think part of what I was getting at is, and that's super helpful, but, and part of what I was getting at is like what happens when we get to that point that Torrey mentioned, and 10 years later we've been monitoring this project, and Jess and I walk out there and the beavers are all gone and all our structures are falling apart, which is pretty much inevitable if you follow the track of these natural populations. What then? Like, how do are we prepared to deal with that? And what kind of, so I guess that, I forgot to ask a question. I did ask a question, but that was a hard one to answer. The actual question would be like, what can we expect? What sorts of frequencies of beaver occupancy can we reasonably expect? And does that change over time? And is that something we need to communicate as we set out and endeavor to do these projects?
He sent us these questions ahead of time, and he said, does this vary site by site and how? And I put, OMG, yes. Because it does vary vastly across the landscape. How long beavers can occupy an area, it depends on how flashy the flows are, how quickly things sediment in, what types of plants they're going after. It can vary. I mean, I feel like this colonization and abandonment cycle in a spring popping out of the hillside might be decades, whereas a stream that's sort of on that transition zone between they don't need dams anymore and they do need dams. There's always a section of stream that's like that as it goes from headwaters down to a major river. In those areas, dams blowing out every single year, catastrophically blowing out every single year, is probably and is really a natural part of that beaver disturbance regime in that system. So I don't have an answer as to how we get to an answer of how frequently we should expect colonization and how long it should last. That's why I always kind of go back to this idea of our indication should be if those structures that were there before are starting to degrade to the point where they're not usable by other beavers, we're going to lose that attractive ability for those dispersers. And that's probably the time where we need to intervene in some way. So I know that's really hard to put on a grant application, but.
I guess one thing I would add, and I think, again, the watershed that we're all sitting in right now is a great example where beavers have to run this gauntlet of so many different land management types of dams and reservoirs and irrigation headgates and urban land use and flow alteration, just so many things that we have done to the system. And so I think that if we want to get to a place where when the beavers do leave, that they can safely come back, we kind of have to start zoomed out, looking at all of those corridors and whether beavers have safe travel into and out of those sites at sometimes fairly large scales. I think Torrey's work, he mentioned that beavers were dispersing up to 10 kilometers. So these are not small spatial scales, but I think if we start there and we enable them to move around, that maybe we can have more realistic expectations about them being able to come and go and occupy areas at some maybe percentage of the entire suitable habitat.
Oh no, I just lost it. Yeah, sorry. When I showed that graph of dispersal distances, I think we all really like to focus on long distance dispersals to be like, oh my gosh, look how far beavers can travel. There's some that are 200 miles or 100 miles. We had several in our study that went 40 plus miles, just completely crossing the stream basin. But if you compare those long distance dispersal movements to what the mean or the median is, whatever it's reported, it's a lot shorter movements. There are a ton of these smaller, shorter exploratory movements, probably related to those beavers staying at home and just constantly checking things out nearby. And so when I think about sites that are really separated by long stretches in urban environments or something like that, I don't think that we can reliably rely on dispersal to be constantly getting through those corridors. And so if we're stuck with those situations, we might start having to act like dispersal acts on the landscape, and that's where we might be looking to do transplants or to try to really develop really good stepping stones along the way.
I don't really know how much time we have, but probably we still have a little bit of time. So one of the things that you're seeing up here is a bunch of professionals struggling with like what's next and how to kind of deal with the complexity of what's before us, and basically trying to restore a keystone species across a massive landscape. And I think another, it seems like most of my good quotes come from Janine Castro, or most of the things I remember, but another thing that I remember her saying once was, when things get really complicated and confusing, just turn back to the science and know what the facts are. And I think we're kind of embarking on this era of a lot of unknowns, and which is basically an opportunity for more science and more research and more answers to some of these questions, because we're looking at things a different way. So another question I'd put out just to this, I'd love to pass this microphone around, but we don't have that much time. But I hope these are all questions that'll start to stimulate some thought and discussion among you all. Since I can't pass this around to everyone, I'll pass it to the folks up here with a question of how we incentivize basic beaver biology and incorporate it into restoration to make this more of a science-based practice, or to keep it science-based. And I have to probably give it to somebody to make them start talking.
Well, I mean, that can go so many different directions. And as I like to say, this is complex. The entire subject of beavers, of ecological function, of ecological restoration, it's complex, and there's a lot of different avenues, much like a web, a spider's web, or like three-dimensional, more like a black widow's web, honestly. Helping resolve people's problems, that's incentive right there, especially if you can do it for free if they're having a conflict issue. But also educating them at the same time, building trust to say, if you want those beavers relocated and I can't talk you into trying coexistence the first time, we'll relocate once with the warning, not in a bad way warning, but like with the knowledge sharing of, this is obviously good beaver habitat. They've found it, they've created it, they've developed it. As Torrey and others have said, the next beavers will come along and find it and prefer it over the more marginal habitat nearby. So you're looking at just a repetitive population sink of relocating or lethal removal of beavers. So if we can resolve a person's challenge or a family's challenge, landowner, an agency's challenge with beavers at that site through a coexistence strategy, that right there is incentivizing living with beavers. You've resolved a challenge, you've increased water on the landscape, maybe biodiversity, resilience. So incentivizing means helping solve people's problems. As Elisa Kerr noted today, a lot of our work with coexistence is helping people work through challenges. And it's very satisfying, and most of the time people do fall in love with beavers. I'd say 95% of the time they get where we're coming from and why it's important. And it's not just a cuddly, cute, furry animal. It's actually a kick-ass engineer who's maybe going to save the world, at least the Northern Hemisphere. But incentivizing by giving people knowledge and being their partner for long term. When we partner with somebody, we're like, it's forever. Not everybody has that establishment yet, but it should be your goal to be the most trusted partner that person can have when it comes to managing conflict with a beaver and then building resilience in their community and encouraging them to recognize themselves as someone who's subsidizing conservation, ecological restoration, sustainability, and resilience in their community. And somehow we've got to bring that to another tier of a goal for people, every person who has the opportunity to live in beaver habitat, to support beavers, to say, you should be celebrated for taking on that burden and also that responsibility, and have partners and support in doing so.
I really, really love that sentiment of sort of appreciating and celebrating the people that either already have an understanding of beavers and are willing to let them stay, or come to that conclusion after learning more about it. Elise had said something that I really, just on the conflict side of things, that when I get conflict calls, I really emphasize with people, which is they call, they tell me what the beavers are doing, and then the next step is, okay, what is the conflict? Like, where is there a problem forming? And it's amazing how many of these conflict calls end at that point. That becomes the opportunity to say, oh no, actually, beaver damming activity is not this inherently bad thing. We actually want it for all of these wonderful reasons. And it's amazing how many times you can suddenly make somebody very proud of having beavers on their property. And so I think that's a big incentive right there on the conflict side of things. And then just briefly, in terms of incentivizing basic beaver biology, I think we are having some of the most powerful tools right now where we can map beaver dams on the landscape. We can get censuses of where beaver dams are located. We can have the BRAT tool. Just those data sets right there, dams and the BRAT tool, is incredibly powerful for figuring out where different restoration opportunities can happen on the landscape. Now, I think the final missing piece, and there's actually a PhD student in Montana that's starting to work on this, is can we model dispersal probability across the landscape? And if we can get those three components, where existing dams are, where dam capacity, what the dam capacity should be, and what the probability of dispersal into that site is, then that just blows everything up, and we can have detailed maps of various restoration strategies across the landscape. And coexistence, yeah, absolutely, yeah. I mean, the BRAT model has that whole coexistence part of it. So yeah, sorry, that is a very important fourth part of it as well, is that. So I think we're well on our way to incorporating basic beaver biology, and I think it comes from these sorts of efforts.
I like all those things. I'll just add that I think we're in this little bit of a kind of a time when beavers are moving from this nuisance species to everybody, obviously in this room, appreciating how important they are, but then kind of bringing that to that wider group, and maybe like some of those studies, it feels like that I wish I had to be like, tell me where to work and when and how much effort and when to go back and maintain it, and some of those pieces that I wish I had that I think really do exist for a lot of other wildlife species that are managed at a state and federal level that are missing for beavers. I think we're just not there yet. So hopefully there's a lot of students out there who want to do that study. And I think that's just a shifting values, and I think we're going to get there, and as much as we can spread the word, and then also spread the word in a realistic way, and so we're not kind of over-promising and setting people's expectations so high that there's some kind of swing on the other side, I think we'll get there. And the other nice part is that yes, we always are going to want more science, but we also have a pretty good working understanding right now. So good work is getting done, even if we might not totally know exactly where some of these thresholds are. We do have a good operational knowledge.
I guess I often work with water managers and practitioners around the state, and I think a really important piece of getting funding to study this very dynamic animal that moves around, when we're incorporating them into things like our state's non-point source pollution strategy, or even things like or just all of these statewide plans where we're saying beavers are important, they're providing these essential functions to us. I think the next step in that is finding out the questions that we need to know about how beavers are moving, to truly understand how much we can rely on their activity, and even better, how we can help support them in doing all these things that we are taking and relying on beavers for. So I hope that in that formal recognition at the state level and maybe on a national level at some point, that we actually put some money behind those purported values and, yeah, really learn what we need to know. Because right now it does feel a little like we're just asking beavers to do everything without fully understanding how they work.
Well, a lot of questions and a lot of things to think about, and thank you, everyone.